Cool. So we'll be doing today one of the same like one of the question of Catalan seek number. You can relate uh, this question with pretty much with that Catalan number. So basically, what it says is like given an integer. Again, you will be given an integer n, and you will have to find the total number of ways to arrange n balanced parentheses. So you can think of it like what example if I talk about, like think of it like this. Balance parenthesis in the sense, if you have been given an open parenthesis, there has to be a closed parenthesis that is closing. Like for example, this is one of the balance parentheses. If there is an opening parenthesis, you need to see that there is a closing parenthesis of the same amount, right? And that is called a balance parenthesis. For example, consider n is equals to 1. So for n is equals to 1, you see there is one balance parenthesis, right? For n is equals to 2, you have like given n is equals to 2, you see how much balance, how much ways or how much ways are there so that you can arrange these balance parentheses. So one of the common approach is either you can like open, close, or open, open, close, close. These are the two ways you can have these balance parentheses, right? And for n is equals to 1, there is one balance parenthesis. For n is equals to 2, there are two balance parentheses. And for n is equals to 0, there is one possible way. And you must be wondering, why is that? For n is equals to 0, why we are considering that there is one balance parenthesis? So remember NC0. By NC0, we say that there's like for selecting like it's a part of common term for like permutations and combinations. When we see that NC0 is 1. So similarly, in this concept also, when you don't have any way, so it's like one way to arrange the balance parentheses. So it's a default term you can think of. And so if you see from the given example, the term like number, if the number is 0, you're getting 1. If the number is 1, you're getting one balance parenthesis. And if the number is 2, you're getting two balance parentheses, and so on. So till here, it's following the Catalan sequence. Like for n is equals to 0, for n is equals to 1, the values are 1 and 1. And for n is equals to 2, the Catalan number says that the number is 2. And for n is equals to 3, you will see there are in a Catalan number there are 5. Like it returns a number 5. And you can also see that here also uh, it shows us 5 balance parentheses. For example, these are the 5 parentheses you can think of. Okay, so now this is just an example I was giving you that how it is relating, how to establish that fact. So let's see one of the approach we were discussing. So one of the common things we do is like in an approach, what we follow. First of all, again, we generate the choices, right? And after the choices, what we think of? After the choices, we think of any journal equation and all. And then form a recursive approach, basically building the recursive tree. So for determining the choices of the given approach, let's think of how these values get changed for various n numbers. For example, we take n is equals to 2. For n is equals to 2, we see, okay, we have one balance parenthesis, we get this number. Now to now what we need to do is, okay, now we see that we have to form two balance parentheses. So the choices are that we know for 1 there is only one balance parenthesis, for 2, but for two balance parentheses we have to identify where we can place this one balance parenthesis. Either we can place at position 1 or we can place at position B, right? So either we can place at position A or we can place at position B. So if we place at position A, like for example, basically this is one of the balance parentheses, and inside it there is a position called A, and outside it there is a position called B. So if you place this balance parenthesis inside A, in basically at position A, so you will get this balance parenthesis. And similarly, if you place at position B, you will get this parenthesis. Is this point clear till here? Hey guys, are you listening?
Yeah, clear.
Sorry.
Clear. It's clear.
Okay. Cool. So similarly, for n is equals to 3, what we can think of is like we have one balance parenthesis, and to place the remaining two balance parentheses either at position A or at position B, what we're gonna do? Like definitely there would be like these, like I told you that we have to place these remaining two balance parentheses. So what we need to do is like either we can, as I was telling, that we can place both these parentheses at position A, or we can place both these parentheses at position B, or what we can do is we can put one balance parenthesis at A and one at B. Like similarly, these will be the combinations like we can think of. So these are the choices I was talking about, right? As you increment the n, similarly, like for three balance parentheses, we can put here, or one and two here, or two here, or one here, and hence the things choices will be different, right? So accordingly, my answer was like that. Like if I place both at position A, this is how it gonna be formed. If it's placed like one at A, or two at like one at A and one at B, this will be formed. Like this is how these things will be formed, right? So if I want to relate the same with the Catalan number, so see this like this. So for n is equals to 3, how I was thinking. Uh, as I was telling you that you can place at position A, this inside is position A, you can place at position B, the outside is position B, or you can place at position A, which is inside, or you can place it at position B, which is outside, right? So what basically you're placing at position A, you're placing both parentheses, the two parentheses, right? So these two parentheses, now you would see the, like if you place both these parentheses here, you are forming this, right? And one of the thing is you want to note these two parentheses which are coming are in what form. By what form I mean, it can be, let me show you this one. So you remember this one we created. Now the two parentheses can be of this form, or it can be of this form, right? If I am choosing this parenthesis, right, this balance parenthesis inside at A position, so I'm forming this one, right? So what I'm trying to say here, if I'm placing this two balance parentheses, because we need to place these two parentheses, right? So we have already placed, right? One we have already placed. So we have to place two balance parentheses. So the two balance parentheses can have choices either this or this. Now, if I want to place this two balance parentheses, I can form this one, this combination. And if I want to place this balance parenthesis at position A, I can form this one. Does this make sense first? Right? This is what I was explaining here, right? Does this make sense?
Yeah.
Yeah. So
Yeah.
yeah. So you see, this is how I'm relating the sequence. Like you have with the Catalan number, how I'm relating the sequence. uh First of all, let me describe this one as well, these two as well, so that I can help you understand the sequence now with the Catalan number. So now if you see, if I have like this like position, I can place it here, or I can place it here. So I have these two combinations. Okay, so out of these two combinations, I can only choose one combination. Can you identify at which position I can place either at B or B? I'm just giving you one hint. Like I'm saying here, out of these two combinations, I can place only one combination of balance parentheses. So it can be at A or at B. Can you identify which one it is, and which I am choosing out of these two? So you have to identify: am I placing the first, or am I placing the second one?
Anyone we can place, right?
Okay. And how about you, Chetan? Chetan, you're thinking.
Can you repeat the question? Sorry.
Yeah. So I was saying that, okay, so you have to place two balance parentheses, right? Either at A
Hmm.
position. Now we have to place these two balance parentheses. You can place either at A or at B. Like you cannot place all
Hmm.
the two parentheses inside A because that combination is here, right? So you have to place two balance parentheses, and you have to choose where should you place. Like, should you split these two parentheses, or what you will do? Like, how will you make sure that which combination you will pick from these? Will you be able to pick the combinations, or anyone can be picked or not? Like, just wanted to think, like, what are you guys thinking?
I think anyone can be picked.
Okay, let's think of if I place these two, right? One, so yeah, so if I place this one, so what I'm thinking, okay, one, the in this position, the first one, like the second, this combination I'm picking. So what I'm doing,
Hmm.
I am placing this combination at inside position and at A position, and I'm placing this combination at position B. Right? This makes sense, Hana? So it's
Hmm.
like
Right.
open, close, open, close. This is forming, right?
Right.
And can I place these two combinations at position A or at position B? Like, it's like open, open, and close, close. Can I place there like open, open, and close, close? Can I place like that?
Hmm.
So
And
basically, the
not
objective is
really.
at whatever position you are placing, either at A or B, it should be balanced. For example, when
Oh,
I place this one at position A, or because I split it, right? I split it this into like one
hmm.
one, right? So whenever I'm placing
Right.
so I'm placing a balance parenthesis inside it, and here also balance parenthesis, right? So I can't split
Right.
this, right? So I can't split, like, even if I can split it, like I can split like this, right? I can split like this, but isn't forming a balance one, right?
Right.
So I think we can place only this one and not this one. Understanding what I'm trying to say?
Yes. 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 What your point?
Cool. And similarly, if you want to pick, if you want to place these two balance parentheses at position B. So you have placed inside, similarly you can place outside. How you can place? Basically, you can choose either like this, like you are forming like this, it will form open, close, open, close, open, close, it will form like you'll just place these two parentheses here. So it will form like this, right? And if you place this combination outside, so it will form like this, open, like how it is, open, open, close, close. So you'll be forming like this, open, open, close, close, right? So now,
Right.
now let's understand how you can relate with a Catalan number. From here, you're getting two sequence. From here, you're getting one. From here, you're getting two again, right? Now, uh, does this make sense? How am I relating that? Like from this parent, like from picking these two balance remaining two balance parentheses, you are basically, now what you are basically doing, you are first of all basically from this result, basically you have two combinations. From this result you have only one combination here, and from this figure you again have two combinations at the outer layer. Is it making sense, guys?
Right. But one of my question is why it is like C0, C1, and
Why? Acha. Why it is like C0, C1? Okay.
C1.
Remember, I told you for like unique BST. What did I told you about? You can relate the same fact. The same, like if I was talking to you about this, right? Remember, for this unique BST, what I wanted to show you. Just consider that for this branch, when you draw a tree for that, right? When we were drawing a tree, the left branch had a 0, no subtraction. So we were replacing with 0, and the right branch has only one term. So we were representing it as 1. Similarly, here for this, the right one had 1 and this left one has 0.
This one has 0.
Right, for n is equals to 0. Similarly, for n is equals to 3, what we were doing, like the first term has 0, right? No, nothing is there. And the second term, right, has 2 child. So we can represent it in 2 ways, right? So we showed by 479 or 497, right? These two.
Right.
Now for 7, taking 7 as a root, what we can do, we can make sure that the left one has only one way we can represent. The right also can have only one way. Similarly, if we take 9 as a root, we see that, okay, we have 4, 7 on the left and 0 elements on the right. So we know we can represent this 4, 7 in 2 ways and the right one by only one way, right? So this is how, like, I showed you the numbers 947 and 974, right? Similarly, when you draw a tree for the same, when you draw the tree for the same, this one, it was there. When you draw a tree for the same, you will see that this is nothing but similar on the similar lines.
Got it.
Got it?
Good.
Yeah. So C2, these will represent 2 terms, 1 and C2 into C0. This is 1 term only, right? And this is like first term would be 0 because nothing would be there, and on the right will have 2 branches. Like this 2 combinations would be there. Cool. I'm stopping for now. And हाँ भाई लोग, क्या पंगा है? ट्री का कुछ